Hey everybody, it's Jenny from Norman S. Wright. We're going to continue on talking about pumps. This week I want to talk about the pump affinity curves. So let's get started. In a past video, I discussed the fan laws that give you a relationship between CFM, RPM, pressure, and power. Well, pumps have two sets of affinity laws. The first set of affinity laws has to do with changing the pump speed. So let's draw a pump real quick. The pump speed in RPM is how fast the motor rotates the impeller. The first law is that the pump capacity in GPM is proportional to the pump speed in RPM, and it's written like this. Q1 over Q2 equals N1 over N2, and then you can rearrange that to be Q2, the new capacity, is equal to the old capacity, Q1, times N2, the new RPM, over N1. To make the math easy, let's say we have a pump with a capacity of 100 GPM. It has 10 foot ahead, it's operating at 1,000 RPM, and has a 5 horsepower motor. What happens if we double the RPM? So now Q2 equals 100 times 2,000 divided by 1,000. That would give us 200 GPM. So when we double the RPM of the pump, we double the capacity of the pump. The next law relates the head to the square of the RPM. So H1 over H2 equals N1 over N2 squared. Then that can become H2 equals H1 times N2 over N1 squared. And now let's put that in here for our example. And we have 10 being the old head times the square of 2,000 divided by 1,000. And that gives us 40 feet ahead at our new RPM. The third affinity law says that the brake horsepower is proportional to the cube of RPM. So we have brake horsepower 1 divided by brake horsepower 2 equals the cube of N1 over N2. And we can rewrite that to be brake horsepower 2 equals brake horsepower 1 times the cube of N2 divided by N1. So let's put in our numbers here. So we have 5 horsepower times the cube of 2, and that gives us a brake horsepower of 40. So let's put all this down here. At 1,000 RPM, our capacity was 100 GPM, our head was 10 feet, and our brake horsepower was 5. At 2,000 RPM, our GPM doubled to 200, our head went to 40 feet, and our brake horsepower also went to 40. Let's scoot this over and look at the second set of pump affinity laws. The second set of pump affinity laws has to do with changing the impeller diameter. So let's draw in our pump again and our new larger impeller pump. So again, the first affinity law in this set is that the capacity is proportional to the diameter of the impeller. So Q1 over Q2 equals D1 over D2. And you can rewrite that as Q2 equals Q1 times D2 over D1. And now again, for easy math, let's say we have 100 GPM, 10 foot ahead, 1,000 RPM, and 5 horsepower. And let's say we have a 7-inch diameter impeller. So let's put those numbers in and double our impeller size. And so we get Q2 equals 100 times 14 divided by 7 equals 200 GPM. The second law in this set is that the head is proportional to the diameter squared. So we have H1 over H2 equals D1 over D2 squared. We can change that to H2 equals H1 times D2 over D1 squared. And if we put in our numbers here, we get H2 equals 40 foot of head. And then the third law is that the brake horsepower is proportional to the diameter cubed. So brake horsepower 1 divided by brake horsepower 2 equals the cube of diameter 1 divided by diameter 2. Again, we can write that. Let's make a little more room. We can write that as brake horsepower 2 equals brake horsepower 1 times the cube of D2 over D1. And when we plug in our numbers, we get 40 horsepower again. So let's write this over here. With a 7-inch impeller, we had a capacity of 100 GPM, a head of 10 feet, and a brake horsepower of 5. And when we doubled that to 14, we got a capacity of 200 GPM, a head of 40, and a brake horsepower of 40. Let's bring all of this back on screen. You can see how the pump affinity laws allow you to determine the change in the pump performance based on a change in the pump RPM or impeller size. This is particularly helpful if your system changes after the pumps are installed, or if you need to replace an old pump that's been in operation with a different pump. So those are the pump affinity laws. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.